The world is changing faster than biology can keep up. Cities glow through the night. Highways cut through forests. Oceans carry plastic instead of silence. The air grows warmer. Seasons shift. And the old signals of nature are becoming harder to trust. But in the middle of all this noise, birds are still trying to adapt. A small great tit perches on a street lamp in London. Below it, traffic roars. Engines growl. Tires hiss on wet pavement. The sound of the city fills the air like a wall. So the bird changes its song. City birds are singing at a higher pitch than their forest ancestors, lifting their voices above the low rumble of human machines. They are not waiting for the city to become quiet. They are rewriting their music to survive inside it. Evolution is not only ancient history. Evolution is happening right now. In our streets. On our rooftops. In our backyards. Welcome to the Anthropocene, the age where human activity has become one of the strongest forces shaping life on Earth. For birds, this age is both a crisis and a test. Some species are learning to live beside us. Some are adapting in real time. Others are disappearing before they have a chance to change. The first signal is sound. For millions of years, birdsong moved through forests, wetlands, grasslands, and open skies. It carried territory, courtship, identity, and warning. But cities changed the acoustic world. Traffic noise masks low frequencies, forcing some birds to sing higher, louder, or at different times of day. A song that cannot be heard is not just a lost melody. It is a failed message. If a male cannot be heard, he may not attract a mate. If an alarm call disappears into traffic, danger arrives without warning. Noise pollution is not only annoying for birds, it can cost energy, reproduction, and survival. The city is forcing nature to speak in a new frequency. But sound is only one part of the transformation. As the planet warms, bird bodies are changing too. In colder climates, larger bodies help animals conserve heat. This is known as Bergmann's rule. But as global temperatures rise, some birds are becoming smaller, allowing them to release heat more efficiently. Every millimeter matters in a warming world. A smaller body can cool faster. Longer wings may help with efficient flight. Tiny anatomical shifts, measured across decades, show us that climate change is not an abstract theory. It is entering the bones, wings, and bodies of living animals. Museum specimens from the past are becoming time capsules. A bird collected a century ago can be compared to a bird living today, revealing how bodies have shifted under the pressure of heat. The climate is not only changing where birds live, it is changing what birds are. Then comes the ocean. An albatross glides over the vast Pacific, wings stretched like a living aircraft. It can cross enormous distances, reading wind and waves with ancient skill. But beneath that blue surface, a new enemy waits. Plastic. To an albatross, a floating red bottle cap can look like food. A fragment of plastic can look like squid. A parent gathers what it thinks will feed its chick, returns to the nest, and delivers debris instead of nourishment. The tragedy is almost impossible to watch. The future of the species is being fed a diet of dead-end material. Plastic fills the stomach but gives no nutrition. It takes up space meant for real food. It can injure, poison, or starve the chick from the inside. The ocean has become a trap disguised as abundance. But the future of birds is not only a story of loss. It is also a story of comeback. In the 20th century, the peregrine falcon, the fastest animal on Earth, was nearly erased. The pesticide DDT moved through food chains and weakened the shells of falcon eggs. Mothers tried to incubate their young, but the eggs were so thin they broke beneath the weight of the parent. A species built for speed was being destroyed by chemistry. Then humans changed course. DDT was banned in many places. Conservationists began captive breeding programs. Scientists, falconers, and wildlife teams worked together to restore the species, and the peregrine returned. Not only to cliffs and wild landscapes, but to cities. Skyscrapers became artificial cliffs. Urban pigeons became prey. The world's fastest bird adapted to the architecture that once seemed unnatural. This is what hope looks like in conservation. Not perfection. Repair. The peregrine comeback proves that damage can be reversed when science, policy, and commitment move together. Today, conservation is entering a new era. In deep forests, tiny sound sensors are being strapped to trees. They listen day and night, recording thousands of hours of calls. Wind, rain, insects, and silence. Human ears could never process it all. So we use artificial intelligence. Machine learning can scan the noise, identify rare bird calls, and track endangered species that humans may never see directly. A hidden bird in a dense rainforest can be detected by its voice. A species thought lost can become visible again through sound. AI is turning the forest into data. And in the right hands, data becomes protection. Satellites can detect illegal logging. Drones can monitor nests without disturbing them. Thermal cameras can find hidden chicks before construction destroys their habitat. Citizen science apps allow everyday people to record birds, identify songs, and contribute to global databases. The future of conservation is not only binoculars and field notebooks. It is sensors, satellites, algorithms, and millions of human observers working together. But technology alone is not enough. Birds need places to live. They need wetlands, forests, grasslands, coastlines, islands, deserts, and migration corridors. A restored marsh is not just a home for egrets and herons. It filters water, stores carbon, buffers floods, and supports entire food webs. Saving birds also means saving air, water, soil, and climate stability. A patch of green in a city may look small, but to a migrating bird, it can be a refueling station. A community garden can become a life-saving island in a concrete ocean. A green roof can become habitat. A native tree can feed insects. Insects can feed chicks. Every piece matters. Migration corridors are the invisible highways of the world. Birds do not recognize borders. They cross countries, oceans, continents, and political boundaries with no passport and no permission. So their survival demands cooperation. A bird protected in one country may be killed by habitat loss in another. A wetland restored in one region may be useless if stopover sites disappear farther along the route. Conservation must think like migration. Long distance. Connected. International. Then there is the silent urban killer glass. To a bird, a window may reflect trees, clouds, or open sky. It does not look like a wall. It looks like a path. Every year, countless birds die by striking buildings they cannot understand. But this problem can be solved. Bird-safe glass, UV reflective patterns, decals, screens, and better architectural design can make surfaces visible to avian eyes. We can build cities that do not function as invisible traps. The question is not whether we can change. The question is whether we will. Light pollution is another threat. During migration, artificial light can pull birds off course, trapping them in glowing cities until they circle from exhaustion. Turning off unnecessary lights during peak migration can save millions of lives. Simple actions can matter. A darker skyline. A safer window. A restored wetland. A cat kept indoors. A pesticide avoided. A native plant added to a garden. These are not small gestures to the bird that survives because of them. The future of wings also raises difficult questions. Can we bring back what we lost? The dodo. The passenger pigeon. Species erased by human appetite, expansion, and carelessness. With advances in genetics, de-extinction is no longer pure science fiction. Scientists can study DNA, edit genomes, and imagine restoring vanished forms. But the question is not only whether we can, it is whether we should. If the habitat is gone, where would the species live if the same human pressures remain? Are we reviving life or repeating failure? Do we have the wisdom to undo extinction? Or only the technology to imitate resurrection? The Dodo Project is not just about a bird. It is about responsibility. The past is asking whether the future has learned anything. At the same time, birds are inspiring the technology of tomorrow. Engineers watch starling murmurations to design drone swarms. Thousands of birds can turn, twist, and flow at high speed without collision, following simple local rules that create complex collective movement. A flock becomes a living algorithm. Humans are learning from that. Biomimicry reminds us that nature is not outdated. It is the original laboratory. The wing, the feather, the flock, the beak, the nest, the migration route, each is a design, refined by millions of years of testing. We do not protect birds because they are fragile decorations of the sky. We protect them because they are teachers. They show us how to adapt, how to navigate, how to cooperate, how to recover, how to survive. But the warning is real. In some regions, bird populations have fallen dramatically over the past decades. A world with fewer birds is not only quieter, it is less stable. Birds control insects, spread seeds, pollinate flowers, clean carcasses, and connect ecosystems across continents. A birdless world would not simply lose beauty. It would lose function. It would lose memory. It would lose a language older than humanity. And yet, life remains resilient. Birds nest in abandoned buildings. Falcons return to city towers. Crows learn traffic systems. Warblers still cross oceans. Condors rise again from the edge of extinction. Kakapos survive because humans decided they were worth saving. Nature can recover when pressure is reduced. Hope is not passive. Hope is work. The future of wings is being written now. In legislation, in gardens, in science labs, in forests, in cities turning off lights, in communities restoring marshes, in children putting up nest boxes, in researchers listening to soundscapes, in ordinary people choosing to notice. Protecting birds is not just about the sky. It is about the future of our planet. Because birds are messengers of planetary health. When they vanish, something is wrong. When they return, something is healing. So the next time you hear a bird singing above traffic, listen closely. That song is adaptation. That song is resistance. That song is a warning and a promise. The world is changing. But the future is not finished. And if we protect the wings above us, we may still protect the world beneath them.